The next example, we want to solve by graphing the system as usual. So we're going to be graphing y equal to negative x squared plus 4, y equal to negative 1/2 x plus 1. Let's move that down. And y equal to 1. And then we note now if the lines are solid or dotted. So if it says or equal to, solid, solid. So these are both solid. Oops, let's change the color on that. So these are solid, solid, dotted. Okay, so let's graph those and then we'll find the intersection points. Okay, so we graph our system. That didn't turn out too well. Let's try that again. Okay. So there's your y-axis, and then we put in our x-axis. As usual. Okay, so then we have parabola, opens down, right, up 4 units. Then we have a line, y-intercept is 1, and then a negative slope. So it's like basically like that, approximately. Then we have a dotted line horizontal at 1. So you graph them all in the same coordinate system. So up 4 units, 1, 2, 3, 4. And then we'll do that one in a different color. I'll try to do that at least. And then it's opening down. So it's here and it's solid, it opens down. And you can just count up 1 over 1, and then 2, 1, 2, 3, 4 actually hits right there. 1, 2, and 4. Okay, so that's what our graph's going to basically look like. It's going to be down like that, and down like that. Okay. Then we have our line, slope of 1. Let's change the color. So slope of, not slope of 1, I'm sorry. Slope of negative 1/2. So it's a negative slope in this orientation. And it's intercept of 1. So you're up 1, and then up 1, and then to the left 1, 2. Up 1, to the left 1, 2. Or you can say down 1 and to the right 1, 2. So it's going to intersect right there. So you have this, and it is solid, like that. And we know that intersection. We're going to need to find this intersection point right here. So this intersection point is not obvious. We're going to have to solve for that one. It is solid. It's a dot because both are equalities. And then we have one more to do, y greater than 1, which means it'll be up. So we can, since y is on the left-hand side, we can actually read these off up or down, basically. So y equal to 1 is our next one. Let's change that to green. And it is this y equal to 1. Like that. So that's y equals 1. And let's label this one. That's y equals negative x squared plus 4. And let's label this one is y equal to negative 1/2 x plus 1. We're going to need to find this intersection point right here, which will be a circle. Like that. Let me zoom in. So that'll be a circle. It's not including those values in the middle. So this will be open like that. So it doesn't include that value, but you got to label what it is. So let's talk about the shading as well. So we can do that actually before we find those intersection points. So If y is on the left, then you can read it off. So the y value, do my pointer here, the y value is less than or equal to the parabola. So it's below it. So you're going below all of that. And then the next one, the y value is greater than or equal to the line. So that's going to be here. So here's your line. So it's going to be above. Okay, getting a picture what that's looking like now? And then y greater than 1 is above the line. So it looks like it's within this region here. So we're going to shade that, and since I have a bunch of colors running around, we'll just do that in gray. Okay, so this, let's increase that size a little bit. So this is gray. All of that, and all of that, and all of that. So where the graphs intersect, we need to know. And I didn't mean to do it quite like that. I meant to do that in gray. Okay, because I wanted to be shaded. Okay. It's shaded like that. Okay. Yeah, let's change that back to white. Okay, so that's our region, but the intersection points are next. So we set them equal and solve. So we have the line and the parabola to set equal. Okay, so you have negative x squared plus 4 equal to negative a half x plus 1. And then we solve that. So 0 is equal to x squared minus a half x, and subtract the 4, and you get a negative 3. Okay, then we can multiply to get rid of that fraction by 2. Let's multiply by 2, so you get 0 is equal to 2x squared minus x minus 6. And then you try to factor that nicely with integers. So you get 2x and x. And then you want the product, so you have 6. 6 is 6 and 1, 2 and 3. So you want the product to be a difference of 1. So 2 times 3 is 5. It's too big. So 2 times 2 is 4. And then minus 3 is 1. If you're looking at that. So this has to be a 2. So x minus 2. And this will be a plus 3. So then 2x plus 3 is equal to 0, or x minus 2 is equal to 0. So 2x is equal to negative 3, or x is equal to 2. X is equal to negative 3 halves, or x is equal to 2. So those are your two possibilities. So the x equal to 2 isn't part of our solution, actually. That's down here. So x equal to 2 is this point here. Well, so we're not including that one. We're really just interested in this one. So that one is your negative 3 halves. So if if x is negative 3 halves, you got to find your y. So use the line. It's easier. So use the line. So y is equal to negative a half. X, which is the negative 3 halves, plus 1. So we got to simplify that and add it up. So that's going to be equal to a positive 3/4. And then 1 will be 4/4. So that'll be 4, 5, 6, 7. So 7/4. So your y value is 7/4. So this point up here, we got to label that, is going to be your x value is negative 3 halves, and your y value is 7/4. So that's definitely not obvious to just write there. So we'll put that up here, and we can shrink that a little bit so that it fits in there nicely. Okay, so that's that point. Then you just need to find the other point. So your other point has to do with this line and the intersection of the parabola. Okay, so that's just 1. So if y is 1, solve for the parabola. So going back up here, we're saying y is 1, put it here, and then solve for your parabola. This is your parabola. So if y is 1, put it here, and then you solve. And that'll be that point. Okay, the work really is in finding these intersection points, not the shading. This is the more difficult part of it. Okay, I'm going to zoom out a little bit so I can see everything. Hopefully there's plenty of space when you look at this to do it. So 1 is equal to -1/2 x plus 1. Okay, so I just substituted in there, set the equations equal, and now I'm going to solve. So I get 1/2 x equal to 0. No, I'm sorry. I just did the wrong one. Yep, I did the wrong one. So let's see what I did there. I wanted that to be the parabola, and I did not write the parabola down. Right? So I'll write it out this time. So I want the I want the horizontal line to equal the parabola. Now I have a roadmap of what to do. Horizontal line is y equals 1. And the parabola was what? -x squared plus 4. Okay, so that's sometimes what you got to. That's why I like to write stuff out like that, so I can see what's going on. X squared is equal to 3. So x is equal to plus or minus √3. So your minus √3 is on the left. Your plus √3 has to be on your right. So that ordered pair has to be your positive √3, and then y is your 1. So that's the one we'll use. I'll just copy that again, bring it up here, and we can make it a little smaller so that it fits in there nicely. Okay, so that's it. That takes a bit of work to do all those. Let's do another one. So try this example. The next example, I want you to try, it's number 54 in the book. So example number 54 is, so what I'll do this time is I'll just write out the question, and then when I post the video, I'll also be posting the notes, and I'll have it all worked out so you can double check it once you get your notes. Let's do it that way this time. Save a little video space. So y greater than x. X squared plus y squared is less than 100. Y greater than or equal to x, and y greater than or equal to 1. So that's our system. So you have a circle centered at the origin. And what's your radius? It's 10. Yes, r is 10. So your center is 0, 0. R is equal to 10. Okay, so make a big circle when you do this, and then you got to find all the intersection points as well. Note which ones are dotted, which ones are positive. Okay, so try that, and that completes chapter 5, which is plenty for the week. And then I'll reevaluate where we need to be next week, going into chapter 6, and then the test will be after that sometime. So after next week. Okay, so look this up in the notes after you're